Okay, guys, so in this lesson of section 6.3, what we're doing is we're talking about the converse of what we did in section 6.2, okay? So in section 6.2, we were given that it was a parallelogram, and then we had those 7 different properties that we could state were true because we were given it was a parallelogram, all right? What we're doing today is we're trying to prove quadrilaterals as parallelograms, all right? So we're instead, rather than being given that it's a parallelogram, we're now trying to prove that it's a parallelogram, okay? Now, there's 5 different methods, all right, in order for us to prove quadrilaterals to be parallelograms. The first 4 are going to sound very familiar, all right, from what we did in section 6.2. It's the last one that's a little bit different, okay? So I just want to do one final recap, all right, just to kind of compare what we were doing. Section 6.2, we were given a parallelogram and then we made those 7 properties, all right? This time we are given some information in order to prove that it's a parallelogram, okay? So, if we quickly read through these, all right, number 1 says that if we could prove, all right, that the opposite sides are parallel, all right, that both sets of opposite sides are parallel, then we know that the quadrilateral is a parallelogram, okay? Number 2 says if the opposite sides are congruent. So if we have 2 sets of opposite sides that are congruent, then the quadrilateral is a parallelogram. All right, number 3 is saying if the opposite angles are congruent, so 2 sets of opposite angles are congruent, then the quadrilateral is a parallelogram. Number 4, if we can prove that the diagonals bisect each other, then we know that the quadrilateral is a parallelogram. And so these first 4 are all similar to the properties that we studied in section 6.2. This last one's a little bit different. This one is saying if you can prove that one set of opposite sides are both congruent and parallel, then the quadrilateral is a parallelogram, all right? Which means that if I have this quick picture, all right, I have this quadrilateral. Right now, I don't know that that's a parallelogram, right? Okay, what I'm trying to prove is if it's a parallelogram. So if I could prove that this set of sides are both parallel and congruent, all right, then that would be enough information to state, all right, that that's a parallelogram, okay? They have to be on the same side. So what you couldn't do is have, if this is another picture, you can't prove that these are parallel and these are congruent. That's not enough information, okay? Okay, so this first prompt, all right, is going to ask us, does the given information permit you to deduce that this quadrilateral, all right, is a parallelogram? Okay, so we're trying to prove that ABCD is a parallelogram. Okay, so just yes or no. So if you look at the first one, all right, we're given that AD is parallel to BC, and then we're given that AB is parallel to DC. Is that enough information to state that that's a parallelogram? Yes, it is. All right, and that's by that first method. If we can prove that opposite sides are parallel, then the quadrilateral is a parallelogram. Okay, let's try the next one. If I know that AB is equal to DC or congruent to DC, is that enough information to state that that's a parallelogram? That's a no, all right? And that's because you need to have both sets of opposite sides to be congruent in order for it to be a parallelogram. And in that one, we just had one set, okay? All right, same idea. If angle ABC, which is this angle, is congruent to angle ADC, is that enough information to state that that's a parallelogram? The answer to this one is also no, all right, because we don't have that the other set of opposite angles are congruent, all right? So just one set of opposite angles being congruent is not enough to state that the quadrilateral is a parallelogram, all right? Next one, if I know that angle ADC, so angle ADC is equal to angle BCA, so angle, I read that wrong, sorry guys, okay. Let's try that again. All right, angle DAC, so this angle, is equal to angle BCA. And then angle BAC is congruent to angle ACD. Okay, so this one's a little bit different. And right away, it probably doesn't look, all right, like that it's a parallelogram. But what I want to do is highlight the angles that we're looking at. So let's look at this angle right here, okay? And then this angle right here. All right, so those are marked as congruent. And so what type of angles are they? Well, they are alternate interior angles. And if we know that the alternate interior angles are congruent, what do we know about the lines that create them? They are parallel. So we know then, all right, that this side is parallel to this side. Now we only looked at one set of alternate interior angles. Now let's look at another set. All right, so let's look at this BAC, and then let's look at DCA. All right, once again, all right, alternate interior angles are congruent, which means that the lines that create them are parallel, which means that this side is also parallel to this side. All right, and in this case, we have two sets of sides that are parallel, which means that yes, this is a parallelogram. Okay, so I'm going to pause here. Next prompt is doing something pretty similar to this.